Today we're going to take a look at Punnet Squares. A Punnet Square is simply a graphic way of helping you figure out genetic problems. This is what it looks like. This one's got the mom on the top and the dad on the side. There are a few words we need to know before starting. First of all, let's talk about alleles. An allele is a term we use to describe a certain form of a gene. Think about them like ice cream flavors. You could have strawberry or you could have chocolate alleles. Some genes only have two options or flavors. Other genes might have three or more. So another allele might be pistachio. We're also going to need to talk about the terms dominant and recessive alleles. If an allele is dominant, it will have more of a say in what the outcome of a cross is going to be. If the allele is recessive, you'll only see it if it isn't crossed with a dominant allele. It's like hats. Pretend you have two copies of a hat gene. Remember, the reason you have two of them is because one copy of the gene came from mom and the other copy of the gene came from dad. The dominant allele might be a bright red cowboy hat and the recessive allele would be a little beanie. If you have two alleles for the beanie, then that's fine. It shows as the beanie. But if you have even one copy of the bright red cowboy hat, that's the only one that will show. In this metaphor, it's like the cowboy hat is sitting on top of the beanie. Dominant allele on top, recessive allele on the bottom. And so we're going to write big H for dominant hat, little h for recessive hat. And remember that all these letters are arbitrary. You can make up any letters you want for any genes, though the dominant allele will always be capitalized, a big letter, and any recessive allele will be lowercase, a little letter. Now we're going to move on to Punnet squares. To start drawing a Punnet square, we're going to draw a square like this with two lines. Look, we've got four boxes. Mom's on top with her eggs, Dad's on the side with his sperm. Each of the boxes represents a possible baby. Baby, 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 baby. What's the probability that any of these boxes occurs? 1 in 4, or 25% chance. For our problem today, we're going to use the gene for eye color. Our two alleles are brown eyes and blue eyes. We'll write brown as a big B and blue as a little b. Brown is dominant to blue, so like the bright red cowboy hat, it's going to sit on top of the blue one. There you go, on top of the blue one. In our cross, mom's got blue eyes. That means she's got to have two copies of the blue eye allele and two little b's. Blue eye, little b, right there, and a little b right there. Now dad has phenotypically brown eyes. What's that mean? His eyes look brown, but this particular dad has one brown allele and one blue allele. He's got genotype big B, little b. That means he's heterozygous for that trait. He's got two different versions. So we're going to take mom's blue eye alleles and give it to each of these babies. They get little b's from her. I, little b, little b, little b, little b. Now we're going to do dad's brown eye alleles and give each of the kids brown eye alleles and big B's for the brown eyes. Now we're going to do blue eyes for his blue allele and give each of the kids little b's for those alleles. This baby up here's got a big B and a little b. That means that we put the brown eye on top of the blue eye. Their genotype is brown eyes. These babies have blue eyes. What does that mean for the probability of the baby's eye color? Remember that each square is going to be 25%, so the chance of a baby with blue eyes is 50%. Let's do this with fractions. Okay, so 1/4 plus 1/4 equals 2/4. 2/4 can be simplified into what? 1/2. What's the percentage of 1/2? Let's see, 1/2 equals 50%. You can also say that the probability is 1 in 2. Alright, so now we have 25 plus 25, or 50% chance of getting a baby with blue eyes, and a 25 plus 25, or 50% chance of a baby with brown eyes. That's how you do a Punnet square. Let's do a little bit more though. You can also use Punnet squares to help you figure out what the parents are like if you have some information about the offspring. We'll start with a blank Punnet square. Suppose somebody tells you you have a big family with about half the kids having blue eyes and half the kids having brown eyes. We know the kid with the blue eyes will have two copies of the recessive allele for blue eyes, so we give little b's to those guys. The kids with brown eyes definitely have at least one copy of the brown eye allele because it's dominant. We don't know though if the other copy is also dominant, a big B, or if it's recessive, a little b. Dad's on the side with his sperm. Mom's going to be on top with her eggs. Sperm, sperm, egg. Ugh, where's my other egg? I lost it. Okay, grr. Alright, so down on the bottom right, this baby has two blue alleles. One must have come from each parent, so we give one blue allele to dad and one blue allele up here to mom. The top right baby has two blue alleles. One came from mom, so the other one had to come from dad. But where did these brown eye alleles come from over here? The big B, mom's got a blank, so that must be there. Brown allele for her. Now we know that the blank had to be the blue allele from dad, so let's fill in mom and dad's genotypes now. All right, mom's got a big B and a little b, dad's got a little b and a little b, dad's got blue eyes, and mom is heterozygous brown-eyed. All done! Now we know everybody's genotype and phenotype. We know what their genes say and what their eye color actually is. And now you know a little bit more about Punnet squares. Give yourself a hand. Good job. The end.